So my main questions up on the board are, what is infinity? Infinity has a symbol that is basically this. Now, infinity in a math class is considered to be the biggest number. So it is, in fact, a concept because there is no biggest number. Any number you tell me is the biggest, I could always add 10 to it and make it bigger. So infinity is a concept. And people struggle with the concept of infinity. It can be tough. Believe it or not, zero is also a concept. Because there are degrees of zero-ness and there are degrees of infinity, as you're going to see when we progress. But the question is, what is infinity? In a math class, it's the largest number. Now, next question. Can you divide by 0? Now, we just watched a video, right? And we always tell you in math class that 1 over 0 is undefined, right? Do you agree with that? Let's choose a number close to 0, like 1/10. Let's choose a number closer to 0, like 1/100th. Then choose a value closer to 0, like 1/1000th. And if you were to continue this process, do you know how to divide by a fraction? You multiply by the reciprocal, stay, change, flip from Pioneer. You multiply by the reciprocal. 1 divided by 1/10 is 10. 1 divided by 1 over 100 is 100. 1 divided by 1 over 1,000 is 1,000. 1 divided by 1/10,000 is 10,000. So if you were to continue this process, as the bottom gets closer to 0, doesn't the value approach bigger and bigger numbers? So you're going to learn something called a limit. A limit is the y value as x approaches something. For example, if I gave you y equaled 1 over x minus 2, we spent time graphing rational functions. So I'm hoping you might know what this graph looks like. What value makes the bottom 0? 2. That creates a vertical asymptote at 2. Now, is the power bigger on bottom than on top? Yes, so it has a horizontal at 0. If you were to put in a 3, you'd get a 1, and it would curve like this. If you put in a 1, you'd get a negative 1, and it would curve like this. Now, my big question is going to involve limits. Limits are usually written like this, Lim. And I want to do it of this. So I'm going to write it 3 times. And we're going to find the value. This is the graph of this. So I'm going to do the limit of 1 over x minus 2. Now, where is it discontinuous? At what x value? 2, right? So I want to do as x approaches 2. And I'm going to put that on all of them. But the first couple are going to be a little different. So I'm hoping you'll watch. I'm going to put a little minus afterwards. Does that mean negative 2? If you want to write a negative 2, do you put the minus in front of it or after it? In front of it. That does not mean negative. It means from the left. Aren't the negatives to the left of 0? So from the left. If you put a little plus afterwards, that is called from the right. And we have to look at those are together called one-sided limits. And we need to explore those. Do you see where x is 2? I want to approach 2 but I want to approach it from the left. Is this close to x being 2? Kind of. Is this closer to x being 2? And I'm coming from the left. Is this closer to x being 2? What does it appear the y value is going towards? Negative infinity, because it continues downward. If you're approaching 2 from the right, so let's do this in a different color just to color code it. From the right, that's this little plus here, from the right, what are the y values going towards as I get closer to 2 from the right? Aren't they going up to positive infinity? For a limit to exist, it has to approach the same y value from the left and the right. From the left, it goes to negative infinity. From the right, it goes to positive infinity. So, do they approach the same value from the left and right? No, one's positive, extreme opposites, aren't they? So when they do not approach the same y value, you have to write the general limit does not exist. Now, do you see how the top two are from the left and from the right? These are one-sided limits. This is not a one-sided limit. This is called a piecewise function. Anytime you see brackets, you have two things, so you have to graph two different curves. The easy one is y equals x. So let's do y equals x in blue. Most of you know that y equals x is a diagonal line, but I don't want y equals x. I want y equals x plus 1. So what does that do? Does that mean the y-intercept is 1? Oops, the y-intercept is 1, and the slope is 1. So do I have a graph of y equals x plus 1, I hope? Any questions about that graph? Now, I did it in blue because that's the one I'm going to circle in blue. I only want it when x is what? Less than or equal to 1. Do you see when x is 1? I don't want anything to the right of it. So I believe I want a closed circle, and would that be my blue one on top? That's the line, but it's only the line when x is less than or equal to 1. Correct? Now I'll do in red, let's do square root of x. Square root of 0 is 0, square root of 1 is 1. If I was to take it out to 4, what's the square root of 4? 2. So I don't know if you know it, but the square root of x is half of a parabola. Where do I want this? Greater than 1. That means I don't want this part over here. And when it's 1, it's a what? Open circle. Would you agree? Please listen extremely close. I'm going to ask for the limit of f of x as x approaches 1 from the, let's do it in blue, 1 from the left. Then I'm going to ask the limit of the function as x approaches 1, but let's do it in red because it's going to be from the right. And then I want to know what the limit of f of x is if it's not a one-sided limit, just if x was approaching 1. That's how you read it, as x approaches 1. Look at the blue ones for a moment, please. As I get closer to 1 from the left, what are these y values getting closer to? Would it be 2? The y value from the left is 2. How about if I approach from the right? What are these y values getting closer to? 1. Do they approach the same y value from the left and right? No. So you would say the limit does not exist on this last one. Does not exist. Because it's approaching a different y value from the left and right. Okay, one more limit piecewise function I'd like to look at. Y equals negative x is in blue. That means your y-intercept is 0 and the slope is negative 1. So that means basically it goes through the origin at a negative 45 degree angle. And y-intercept is 0. You rise negative 1, run 1, and you get this line. Anyway, I only want the line when it's not equal to what? When it's not equal to 2. So that means everywhere else. So where x is a 2, I go right down to there, and I notice that that's an open circle because that's x is 2. When x is 2, what's the y value? When x is 2, the y is what? 0. So here is our graph. We have a line with a hole and a point above it. I want to know the limit as x approaches 2 from the left. Then I want to know the limit of the function as x approaches 2 from the right. And finally, I'd like to know what this limit is as x approaches just 2. The first two are one-sided. The second one is in general. The last one, that is. Okay, I graphed it. I wrote my limits out. I'll give you a moment to catch up. But does everybody see where x is 2? That's where it's discontinuous. That's where it's not continuous, basically. Please watch this because this is slightly different than the first two we've done. As you approach 2 from the left, this point's close to 2. This is closer to 2. This is getting closer to 2. As I get closer to 2, what is the y values getting closer to? Negative 2. As I approach from the right, what are these y values getting closer to? The same y value, right? Isn't it also approaching negative 2? Does it approach the same y value from the left and the right? If it does, that would be your limit for the general limit. I wrote two limits here. The one on the right, I believe I can just simply replace the x with a 3. And when I do that, this limit equals 15. That's called direct substitution. If you can do direct substitution, do it. That's the easiest way to evaluate a limit. But what happens when you put 3 into this? Do you get that magical 0 over 0? This is where the calculus comes in, or the very beginning of it. How do we deal with 0 over 0? 0 over 0 is called an indeterminate form. So if you say 0 over 0, it's called indeterminate. But using special techniques, you can determine the value. Does the numerator factor? Is it the difference of squares? X plus 3 times x minus 3. Could something cancel? What are you left with? What is the x approaching? I think I have the x approaching 3, right? Can I now put in the 3? And what would this limit equal? This limit would equal 6. This technique is called factor cancel. And I'm going to give you 5 techniques. The most direct and easiest is direct substitution. You want to try that first. But if you have an indeterminate form like 0 over 0, or I hate to say it, eventually it might be infinity over infinity, then you might have to use one of these techniques. This is a little more challenging of a question. If you put in a 1, you get the square root of 4, which is 2. 2 minus 2 is 0. Divided by, put a 1 in on bottom, 1 minus 1 is also 0. So I get this 0 over 0 form, and I need to find a way of approaching it. So, please tell me that you know the following. Do you know what A plus B times A minus B would give you? Well, what's x plus 1 times x minus 1? What's x plus 2 times x minus 2? What's x plus 3 times x minus 3? These are the difference of squares. This would be x squared minus 1, x squared minus 4, x squared minus 9. So in general, a plus b times a minus b, which by the way, these are called conjugates. When you multiply conjugates, you'll get a squared minus b squared. Very important concept if you're going to be able to do these limits. Is everybody okay with the fact that a plus b times a minus b is a squared minus b squared? The reason I'm asking is I would like to know the conjugate of the numerator. A minus b. What's the conjugate of a minus b? Well, it would be a plus b. And what is the conjugate? It would be the radical x plus 3, but now plus 2, right? Because it has a plus. So I have to multiply by a fancy form of 1 so that I don't change the value. But my question is, again, what is a minus b times a plus b? What happens when you multiply these? You get a squared minus b squared, just like it says here. Now listen, please. If this is a, what's a squared? X plus 3 minus, because it's minus. What is, if b is 2, what's b squared? Can anybody simplify the numerator? Would it be x minus 1? What do you have in the denominator? Well, you have an x minus 1, but you also have the conjugate that you used, right? Now, could the x minus 1s cancel? And this gives you this. Now, originally, x was approaching a 1, right? So if you put a 1 in for that x, what would I have? Square root of 4, I think, is 2. I believe I would have my limit equaling 1/4. This technique is called rationalizing. How do you know when to use rationalize? Whenever you see a radical or a square root. First off, you got to get 0 over 0. But then, if you see a radical, those are the only ones you're going to rationalize. This is probably the last method I'll be showing you. It's called multiplying by the least common denominator. If I put a 2 in, you get 1/5 minus 1/5, which is 0. 2 minus 2 is 0. So we again get the magical form of 0 over 0. It's called an indeterminate form, and we have to deal with it. When I see fractions and fractions, I usually think least common denominator. So what is the common denominator between my two denominators? You can always multiply them. X plus 3, the quantity, times 5. Again, over itself, so it's a fancy form of 1. When you multiply here, would the x plus 3's cancel? And what are you left with? 1 times 5, which is 5. Minus, when you multiply here, would the 5's cancel? Leaving me what? X plus 3. Now, if you clean this up, you get 5 minus x minus 3, which is 2 minus x. Would you agree with that? On the bottom, you have all of this. You have x minus 2, you have a 5, and you have an x plus 3. I see 2 minus x and x minus 2 is almost the same. If I could take a negative 1 out of 2 minus x, it would turn it into x minus 2. Whenever you factor a negative out of a subtraction, all it does is reverse them. So now the x minus 2's could cancel, and I'm left with this. I'm doing the limit as x approaches 2. So now I can replace the x with a 2, and I get a negative 1 over 5 times 2 plus 3 is 5. 5 times 5 is 25, and that's this one's result. Again, that technique is least common denominator.